Hi everyone, this video is on 1.4 prime factorization. Okay, prime factorization, prime means prime number. It's the number that can be divided only by one and itself. Okay, and then the opposite of prime number is composite number. So prime number, so you need to know what prime number is, and then you also need to know composite. Okay, composite means the opposite of prime. So there are multiple numbers that can be divided into that number. Okay, and some example of prime numbers, and we discussed this in class, and these are not all of them, but there are just some of them. It's 2, 5, 7, 71, 23, 13, 11, so on and so forth. Okay. And composite numbers are other numbers besides these prime numbers. So let's talk a little bit about prime factorization. There are 3 different ways to find prime factorization that we discussed in class. These are not the only 3 ways that you can find prime factorization. There are more ways, and I shared a 4th way that a student, one of your classmates, has shared as well. Okay, but I'm going to focus on these 3 methods and find the way that makes sense to you. So the way that I'm going to show you first is going to be prime factorization. So we're going to find prime factorization. I'm sorry, I said 3 ways. It's going to be 2 ways, okay? It's going to be the factor tree. So let's use 60 as an example. Okay, 60. Now 60, there are different factor pairs. Factor pairs are numbers that can go into 60 that are pairs. Pairs are 2 to come together. Okay, so the first one is going to be, I know 60 can be 2 times 30, so 2 times 30. And how I'm showing you this, there can be different combinations. Maybe you have chosen 15 and 4. Those work perfectly as well, okay? And you can also do 3 and 20. Those also work as well, okay? And they're different combinations and it's different work, but you'll still end up with the same answers later on anyway. But I chose 2 and 30. So now I have to look, 2, is that a prime number or is that a prime number or is that a composite number? If it's a prime number, you circle it and it do not branch out anymore, okay? Because it's going to keep branching out, become 1 and 2 anyway, so it doesn't branch out. 30 is a composite number, so I need to branch out and I need to find another factor pair. And it could be any factor pair, okay? You can do 2 and 15. You can do 3 and 10, okay? It doesn't matter because your answer will end up the same anyway. So try it. I'm challenging you, okay? I chose 2 and 30. I want you to try a different way to see if you'll end up with the same answer, okay? So 30 is going to be, I'm choosing 2 and 15. 2 is a prime number, so I'm going to circle that so it stops, okay? And 15 is a composite number, so it keeps branching out. And 15 is going to be 3 and 5. And 3 is a prime number, so I circle it. And then 5 is a prime number, so I circle it, okay? And how I would write this is it's going to be 60 equals 2 times 2 times 3 times 5, okay? In class, I mentioned that there's standardized ways to write this, okay? You can write 5 times 2 times 2 times 3. That's totally fine. It's the correct answer. But math, we like to standardize things because it kind of makes it easier on the eyes. And also when we're looking at each other and we're comparing and we're sharing and we're collaborating, it makes it easier for everybody, okay? So numerical order is always better, okay? It's not the only way, but it's better. You can also simplify this. So this is where you need to look at 1.2, powers and exponents. Is there a way that I can shorten this, okay? Mathematicians like to write less. They like to simplify things to make it easier on the eyes. So less is also what they prefer. So 2 times 2, you can write that as 2 squared. Multiply by 3, multiply by 5, okay? And this is going to be the best preferred way to write 60. That's just one method. Another way to write 60, to find 60 as a prime number is you can use the hockey stick method, okay? In the hockey stick, a little bit different from the greatest common factor, GCF, is the numbers outside when you use prime factorization can only be prime numbers. Okay, so give me a prime number that can go into 60, and there are a couple of options. There can be 2, there can be 3, you can choose 5. Okay, let's do 3. Okay, and I want you to challenge yourself. Okay, see if you can do 2 and then see if you can get the same answer as I do. 3 can go into 60 20 times. Okay, 20 is not a prime number, so I have to keep going. Okay, find another prime number that goes on to my left, and I'm going to choose 2. 2 can go into 20 10 times. Okay, 10 is a composite number, so I have to keep going on my hockey stick method. Okay, 5 can go into 10, and it's a prime number. 5 can go into 10 2 times, and since 2 is also a prime number, I stop. Now I'm going to look at all my prime numbers. There's 3, there's 2, there's 5, and there's 2. And you look right here, it's the same exact numbers, so it's the same answer. Okay, that's prime factorization. Factor pairs. Factor pairs, there's so many different ways to find factor pairs. I like to do the T-charts. The reason why I like to do T-charts is because it kind of helps me organize it a little bit better. Okay, you can do it a different way, but I like factor pairs. I like T-chart because it just organizes things. So let's use 60 as an example. Okay. I like to start off with 1. 1 and what gives me is a factor pair of 60. That means 60. Okay, because 1 times 60 is 60. 2 is 2 a factor. The answer is yes. Okay, 2 multiplied by what gives me 60, and the answer is 30. Is 3 a factor? Yes. 3 times what gives me 60? It's 20. Is 4 a factor of 60? Okay, that's what you need to kind of think about. Can 4 go into 60 evenly? Okay, don't do these in your head. Do it off to the side. Okay, but yes, 4 can go into 60. Okay, 4, again, don't do things in your head, so you can do it like here. 4 can go into 6 1 times. 1 times 4 is 4. Subtract that, and it's going to be 2. Bring down the 0. 4 can go into 20 5 times. 5 times 4 is 20. Okay, evenly, so it's 15. Okay, now 5 is factor pair of 60. The answer is yes. 5 times 1 gives me 60. The answer is 12. Again, if you can't do it in your head, do it like this. Okay, is 6 a factor? The answer is yes. 6 can go into 60 10 times. 6 times 10 is 60. Okay, 7 is not. 8 is not. 9 is not, and it kind of just loops back. Okay, again, but this is not your answer. This is just your work. Okay, so how you would write your answer would be this: 60. The factor pair of 60 is 1 and 60 because they need to be together. And how you separate them is instead of a comma, you put semicolon to make that difference. Okay, 2 comma 30 semicolon, 3 comma 20 semicolon, 4 comma 15 semicolon, 5 comma 12 semicolon, and 6 comma 10. Okay, so these are all the factor pairs of 60. Okay, if you would like to go over more examples of this, please ask me. But other than that, this is kind of the, oops, sorry, I totally blocked that. Okay, this is factor pair and prime factorization is what you need to know for 1.4. We also learned about greatest perfect square. That's a little bit more complicated to do on the video, but if you want me to make one, I'm more than happy to do so. Or the best way is just to come in and we can talk about it and sit together and do it together. Other than that, stay tuned for the next video. Bye.